So instead of just giving you the product rule, let's actually go ahead and derive it so that we can kind of have an understanding of why it works out the way that it does. So let's start off with a function. We'll call it h of x, and we're going to let h of x be the product of two functions. That's what we ultimately want to be looking at. So let's call it f of x times g of x. And what we want to find is we want to find h prime of x. And just like a lot of these rules that we're going to come up with, we're going to derive it by using the limit definition to figure out what h prime of x is. So h prime of x is going to equal the limit as h approaches 0 of h of x plus h minus h of x all over h. And remember, this function h is different from this value h, which we use to represent that change in x. So don't hang yourself up on that, but we are going to go ahead. H of x plus h, I want to swap it in terms of f and g's. And so this is the limit as h approaches 0 of f of x plus h, g of x plus h. So that would be h of x plus h minus h of x, which is f of x times g of x all over h. So the next step that we're about to do comes from this idea that here in the numerator, I don't have anything I can factor. Nothing is going to really simplify right now, but I do have this idea that's percolating here. And you use this technique whenever you learned completing the square in algebra. We're not going to do any completing the square, but one of the things you did was you did something to one side of the equation, and you could do that through addition or subtraction as long as you did the inverse as well. And so when you did completing the square, a lot of times you would add a number within an expression, and then later on you would subtract it, and you didn't change the balance of it. You just rewrote it in a way that was going to let you do the process of completing the square. And that's kind of the same logic of what we're about to do. I'm going to take the numerator here, and in between these two terms, I'm going to start off by actually subtracting an expression that I know is going to make this thing work. And I can do that as long as I also add it back in. And so what I want to do here is this is going to be the limit as h approaches 0. So I'm going to start off with f of x plus h, g of x plus h. And the expression that I'm going to start off subtracting is going to be f of x plus h times g of x. And the reason why is because this is going to be what allows us to break things off. We're going to get 4 terms. We're going to be able to group them and do a little bit of factoring by grouping. So you can already kind of see there's a common factor here that we'll take out, and some really nice things happen. The only way I can subtract this particular term, though, is if I add it back in. So let's add f of x plus h times g of x. And now I'm going to go back and subtract f of x, g of x. And this is all over h. And so you can see I didn't change the value of anything. I just subtracted this term, but I added it back in, so I didn't change the value of this particular expression. Now what I want to do is I want to take a look at these first two pieces, and remember I can split up this fraction because there's a single term in the denominator. So I'm going to start by looking at the limit as h approaches 0 of f of x plus h, g of x plus h, minus f of x plus h, g of x all over h. And then I'm going to look at plus the limit as h approaches 0 of these two. So f of x plus h minus, times g of x minus f of x, g of x, and this is all over h. And so hopefully my little jumping the gun on the minus sign there doesn't throw you off. All right, let's take a look at each of these terms and see if there's not a common factor in the numerator. If I look at this one, I can factor out f of x plus h from both terms in the numerator. So let's do that. Let's say this is the limit as h approaches 0 of f of x plus h times the limit as h approaches 0. So remember, I've factored this out, and if I look at what I'm left with g of x plus h minus g of x all over h. And hopefully this is something that looks familiar to you. Let's go over here to the other side and see what our common factor that we can take out of the numerator is. It looks like I can take out a g of x. And so let's do that. Let's take out g of x. And I am left with the limit as h approaches 0 of f of x plus h minus f of x all over h. All right, so now let's evaluate each one of these limits here. The limit as h approaches 0 of f of x plus h, that is going to equal f of x plus 0, which is going to be f of x here in a moment. This right here is our limit definition for the derivative of g of x. So I can actually replace this with g prime of x plus limit as h approaches 0 of g of x is just going to be g of x. And then the limit as h approaches 0 of this expression right here, there's our limit definition for f prime of x. And so I get this really interesting result here. So let's go ahead and write what the product rule is. So I can say that the derivative of f of x times g of x, the derivative of a product of two functions, is equal to f of x times g prime of x plus g of x times f prime of x. And there's your product rule right there. And really, it's a pretty easy thing to apply. What it means is that if I take a look at the product of two functions, what I do is I keep the first function and then take the derivative of the second. And then I use the addition symbol, and I keep the second function and then take the derivative of the first. And so there's the product rule right there. And now we'll focus on how to actually apply it and use it to take the derivative of some functions that are expressed as products.